I really love talking about logic and studying logic in mathematics. And it doesn't even have to be in mathematics. We're going to look today at conditional and biconditional statements. And these can be mathematical, but they don't have to be, because the logic applies to both mathematics and to not mathematics, because things are either true or false with logic, and that applies to math and other areas of the world as well. So let's start by reviewing a little bit. We talked about this in the previous video. A conditional statement is an if-then statement. And you have if hypothesis, which we call P, if the hypothesis, comma, then the conclusion, and we call the conclusion Q usually. And just for the sake of making it look pretty, I'm going to write the hypothesis in, or rather, I'm going to write P in red and Q in blue. So the conditional is where we start, if then, and we have a hypothesis and a conclusion. The converse, okay, the converse is where we flip the hypothesis and the conclusion. So the P comes over here and the Q comes over there. Okay, if Q then P. The inverse is where we negate both the hypothesis and conclusion, but we leave them where they are. So instead of P here, this is not P, and this is not Q. Okay, and we use the little tilde. Just for the sake of mentioning it, there is another symbol that is used. Also, the tilde is not the only one. It looks like a little minus sign with a little thing coming off of the bottom, and they mean the same thing. You can either use a tilde or this little, looks like a broken, like an angle or something, or like a little broken minus sign. They mean the same thing. So a contrapositive is the fourth kind of a statement, and it's where you negate. So up here we flipped, here we negated, and here we negate and flip. Okay, and so the not P comes here and the not Q comes there. Okay, and you'll learn in the next video that the law of contrapositives tells you that the contrapositive and the original conditional statement are actually logically equivalent. So if the contrapositive is true, then the original conditional is true, and if it's false, then the contrapositive is false. They have the same truth value. One more kind of statement I want to mention here is called a biconditional. Bi meaning two, of course. And this is when both a conditional, let me just underline this, it's when both a conditional and its converse are both true. Okay, so if the conditional P then Q and the converse Q then P, if those are both true, then that statement is called a biconditional, and you can say that it's if and only if, and you write P with a double-headed arrow like this and then Q. And the abbreviation in math is IFF. Okay, so it looks like a typo, but it's actually not. Okay. Now, I want to talk about the negation of an entire conditional. So here we were negating the hypothesis or negating the conclusion, and you can negate one or both. It doesn't, you don't have to do both, you can do just one, but you can also negate the entire statement. So if you recall here, let's just do this. If you recall, the conditional is written as P implies Q. The converse is written as Q implies P. the inverse is not P implies not Q, and the contrapositive is not Q implies not P. Okay, so you can see we're negating just the Q and the P, but what happens if we negate the entire original statement? And I negate here the entire original statement. Okay, well, that's the same as saying P and not Q. This is a conjunction. Remember, this is a conjunction from our lecture last time. So this is a conjunction because of that symbol right there, and that means and. So P and not Q. Okay. So don't confuse this with just negating the P or Q or both. This is negating the entire conditional statement, not just the pieces. Okay. This is a result of something called De Morgan's laws, which we're not going to study in this class, but it's really important to at least know that they're out there and know that you've seen the name before when you run into it again in life. And I just want to remind you that the little tilde means false. So what this means is that P is true and Q is false. That's what this means. Not Q means that Q is false, and P means P is true. Okay. So now time for some examples. Okay, I want to do some math examples and some non-math examples because I think that it's good for demonstrating how these actually work. So let's start with a math example, or excuse me, a non-math example. So let's say that statement P is you clean your room, and statement Q is you can play video games. Now I hope you all see the connection here. Usually if you clean your room, then you can play video games, right? Because you have to clean your room before you're allowed to play video games. So the conditional, okay, the conditional, which would be P implies Q, would be if you clean your room, then you can play video games. Okay? If you clean your room, and notice that here is my P, if you clean your room, okay, then you can play video games. See how nice that works? Okay. Now let's go on to the converse. The converse is Q implies P. Okay, and let's stop and do the truth value of this. Is this true? If you clean your room, then you can play video games? Yeah, that's probably true. That's probably true. Okay, that's probably true. So what about the converse? Q implies P. So let's just flip it. So, and this is how you do this. You write out the whole statement and then decide if it's true or false. Okay, so if you can play video games, then you clean your room. Okay, so let's think about this. So here is our Q now, and here is our P. We flipped them. If you can play video games, then you can clean your room. Well, that's also true because if you're able to play video games, then you obviously have the ability to clean your room. But let's think about what this is saying. If you can play video games, then you clean your room. Okay? You clean your room. So let's think about that. If you're able to play video games, then do you clean your room? Well, not always. I'm sure that there are some students who would rather just play video games and don't ever clean their rooms. So this is not necessarily true. It's not necessarily true. I can come up with one counterexample, at least one counterexample, and that's all I need to show that it's false. Now the inverse, remember, is the negation of P implies the negation of Q. So if you don't clean your room, then you can't play video games. Okay, so again, you don't clean your room is my P, and here's my Q. Okay? If you don't clean your room, then you can't play video games. Well, that's true. That's true. Because I don't know of anybody's parents that wouldn't say that. Okay? If you don't clean your room, you can't play video games. I'm sure you can hear your parents saying it now. Now the contrapositive is where we take not Q and that implies not P. Okay? So this is if you can't play video games, then you don't clean your room. I would say this is probably also true, because if you can't play video games, then what is your incentive to clean your room? Okay, so I would say that's true. And in fact, we will see when in the next video that the conditional and its contrapositive are always going to have the same truth value. Okay? Okay. You pass the final exam and you get an A for the class. So let's see how this goes. So the conditional would be if you pass the final exam, pass the final exam, then you get an A for the class. Well, that's probably true, right? That's probably true. If you pass the final exam, then you get an A for the class, unless you've been slacking off all year. What about the converse? Okay. If you get an A for the class, then you pass the final exam. Well, no, that's probably false, because if you get an A for the class, then you've already taken the final exam. So it's almost like it's out of order here. Okay. The inverse. If you if you don't pass the final exam, then you don't get an A for the class. Okay, that's probably true. If you don't pass the final exam, then you don't get an A for the class. And the contrapositive, if you don't get an A for the class, then you don't pass the final exam. Actually, I'm going to change my determination up here. So this is obviously true. If you don't get an A for the class, then you probably didn't pass the final exam, right? I'm actually going to change my answer up here to say that by the same logic, if you pass the final exam, then you get an A for the class. Well, let's just say that this is a biconditional. Let me say that this is true also. And what this is saying is that I can go this way or that way. That makes it a biconditional. And that means that passing the exam is sufficient to pass the class, or is sufficient to get an A in the class. Let's go on to a math example. A is an odd integer, and 3A is an odd integer. Now, sometimes these math ones are a little bit trickier, so let's be careful here and look at what this is saying. Okay, so the conditional would be if A is an odd integer, then 3A is an odd integer. Well, let's think about some examples of this, okay? Alright, so if A is an odd integer, so A has to be things like 3, 5, 7, 9, 11, so on and so forth. Then 3A is an odd integer, so then 3A, well, 3 times 3 is 9, 3 times 5 is 15, 3 times 7 is 21, 3 times 9 is 27, 3 times 11 is 33. It certainly looks like an even 1. I forgot about 1 up here, then 1 times 3 is 3. It certainly looks like if A is odd, then 3A is also odd. But if A is odd and 3 is odd, looking at odd times odd equals odd, right? Oops. Odd times odd equals odd, because the 3 is odd and we've already said that the A is odd, so odd times odd is got to equal odd. And if you look at your multiplication table, you'll see that that is true. So this is in fact true. Okay. Let's look at the converse. If 3A is odd integer, then A is an odd integer. Okay? If 3A is an odd integer, then A is an odd integer. Well, let's look at some examples here. Let's look at some examples here. If 3A is odd, then we're looking for what A is going to be. So if 3A is odd, then we're going to see that this means that odd times A equals odd, right? And so, because that's what that is there, because 3 is odd. That means odd times A is odd. Okay. Well, what happens if I do odd times even? So A can either be odd or even, right? It has to be one or the other. What happens if A was even? Odd times even. Okay, what would that give us? Well, let's look at some examples. 3 times 2. Remember, 3 times, we're doing an even one here. 3 times 6. 3 times 2 is 6. 3 times 4 is 12. 3 times 6, is 18. 3 times 8 is 24. I'm getting a lot of even numbers over here. So if A was even, then the answer is going to be even. Okay? All right. So if 3A is odd, it's going to have to be because A was odd. It's going to have to be because A was odd. So if 3A is odd, then A is an odd integer. That's also true. That shows that this is a biconditional, and I can write it either way. Okay, what about an inverse? If A is not an odd integer, then 3A is not an odd integer. Okay? So if A is not odd, then what is it? It's even. And, excuse me. So if A is even, then 3A, as we just saw right here, odd times even equals even. So if A is even, then 3A is even, which is the same as saying not odd. So this is true. And let's finally look at a contrapositive contrapositive. Okay, so if 3A is not odd, then A is not odd. But we already know that if 3A is even, as we saw right here, if 3A was even, then it had to be because A was even. So if 3A is even, then A is even. This has to be true, and also because it's going to have the same truth value as the original conditional. So this is true, 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 true. Okay? And this is something, when you have all truths here or all truths here, you have something called a tautology. Okay? A tautology. And I'm going to write that right over here. Tautology. That is where everything is true. Tautology. Kind of a fun word. Okay, so I've got one more example here to work through. But I've written this in a funny way. I will either wash the car or mow the lawn. What kind of statement is that? I will either wash the car or mow the lawn. Okay, let's see what this is saying. Okay, this is or. Okay, or. So if we say washing the car is P and mowing the lawn is Q. Okay, I'm going to do one or the other. Okay, so really as it stands right now, I could write P or Q, right, using my disjunction here. Remember disjunction? Right, disjunction. But let's rewrite this. If I'm going to do one or the other, then I can say that my conditional is that if I wash the car, then I won't mow the lawn. Right? If I wash the car, which means that P is true, okay, because I'm doing it, so this means P is true. then I won't mow the lawn. And that's saying that Q is false because I'm not mowing the lawn. So Q is false. That's what that is saying. So in this case, my original conditional statement is P implies not Q. Isn't that interesting? Which is perfectly fine, because then we can construct the converse, the inverse, and the contrapositive in exactly the same ways. So if P implies not Q is the conditional, then the converse is we just flip it. Not Q implies P. The inverse is where we negate both. So my P becomes a not P, and my not Q becomes a Q. And here, for the contrapositive, remember that I need to flip and negate. So the not Q comes up front and it gets negated, so it's just a Q. And the P goes to the end, then it does become negated. Okay? So that's what that would look like. So let's write these out. Not Q. So this would be if I don't mow the lawn, then I will wash the car. That's true, because I'm going to do one or the other, so if I don't mow the lawn, then I will wash the car. So this is true, and the conditional was also true. Okay? And notice here, I want to make sure you're picking up the difference between the conclusion and the hypothesis and the whole statement. Okay? So in this case, Q is false, but the whole statement is true. Does that make sense? Okay. All right, what about the inverse? If I don't P, wash the car, if I don't wash the car, then I will Q, I will mow the lawn. Okay, and that's true because I'm going to do one or the other, so if I don't wash the car, then I will mow the lawn. That's true. What about a contrapositive? So if Q, if I mow the lawn, then I won't P. Then I won't wash the car. And I know that this is true because it's always going to have the same truth value, which, I mean, it's true, but it's also going to always have the same truth value as the conditional. And you'll learn about that in the video called Law of Contrapositives.